Well, everyone, today we're going to be looking at arithmetic series. That is when you have a list, a sequence, and you add up all the terms together to see what, well, they add up to. Now, there are two situations that we need to look at. With one situation, that is when you are given the first and the last term of the series. So when you're given the first and the last term. But the other situation is you don't have the last term. You just have the beginning of the sequence, or rather series. And then you need to find the sum of, let's say, the first 200 terms or something like that. So for this video, we're going to take a look at this one here, given the first and the last term. Okay, we'll see what you can see how it works. So an example for you will be a series now where all the numbers are added up. And how about we'll use our we'll use this series here. We'll say 2, 6, 10, 14, 18, 22. Now, I know, and you know I know, you can just punch this into a calculator and be done with it. But the goal is to be able to solve more advanced problems with an understanding of how the formulas and calculations work. So you can add this up, get the answer. I'm going to do it this other way. So first of all, a lot of the symbols are the same as before. So what I see is that I recognize the first term, or the A term, is 2. What I see is that there are, counting them out, 1, 2, 3, 4, 5, 6 terms. So n is equal to 6. And I also can see the last term, which is what this situation is. The 6th term has a value of 22. And the goal is to figure out what they all add up to. And so that's this symbol here. And S, we're looking at the first 6 terms added up. And of course, we don't yet know what it is. But here's how you can do it. There's a guy, a long time ago, as a kid, in fact. I don't know if he had a tutor or just a wicked brain. But his name was Gauss, and he figured out how to do this formula and surprised the heck out of his teacher by adding up, I don't know, first 1,000 terms in he did it in about 12 seconds. You can too, by the way. Right? The formula that he knew, perhaps discovered or was taught, looks like this. Sn, the sum, is equal to the first term plus the last term. Okay? And now, from our list, we can see we have almost all of these things, or if not all of these things. Right? So we can sub them in now and work them out. So the sum of the 6 terms, n is 6, T1, or A, is 2, and then, we put a 6 in there, a 6 in there, so you put a 6 in for the n, right? But we know what this is. That's just 22. So a little sloppy there, but just wanted to show you that when n gets replaced, it gets replaced everywhere. So n is 6, so that's a 6, that's a 6, and that's a 6. But we can improve on that last term here because we know it's 22. Right? So once you get good at this, you don't really need that. You can jump right in and start calculating. Right? So we get something like this, which is 3 times, same as 3 times 24. And so the sum of the first 6 is 72, which is hopefully what you got if you were punching the old calculator and working this out. All right, so what do we have? We had to find the series, the sum of the series. We had to add all these up. We use the same symbols as before and in the same way, except for this new one, which makes sense. We want to sum, which is the result from adding them all up. This is the formula that's going to be new for you. But there it is for now. Explanation as usual can come later. And then all we did is we started substituting it in. Substituting the values in. Put n in there. Put 22 in for T6 there. Right? 2 in for the first term. And just worked it out. And that's how it goes. Here's another example. Same style. We'll say this time we got 3, 9, 15, 21, 27, 33, and 39. Equals what? Well, you might already be done. But here we go. This is how it's going to look. That says solution in a creative shorthand sort of way. So I know that A is equal to 3. I know that N is equal to 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Know that the last term, the value of the last term is 39. And what else? Well, I guess we can write it on the list. We could have even done it last time. The common difference. All right, D is equal to, I go 9 minus 3 and get a value of 6, and hopefully that's the same all the way along here, which it should be, because this is this type is arithmetic. So you're adding the same thing each time. Same add is how we said it. All right? Arithmetic series. So let's find what this, oops, it's not 6 anymore. That was the last question. Now, n is equal to 7, so we want the sum of the 7 terms. So the formula from our buddy Gauss, first term plus the last one. Notice put a in there this time just because, right? But we have n is 7, which might be a little bit awkward for the adding and multiplying, but we'll see what we got. We got now, what's here? 3 is the first, 39 is the last. 7th position goes in there. And so we have 7 over 2 times, this to me looks like it's 42. And so now the calculating part. Well, I'm going to divide this by, this 2 can float around, so I'm going to float it underneath here. So that'll end up being 7 times 21. 42 divided by 2 21. And then multiplying these together for the greater glory. 7 times 2 is 14 with a 0, 140. Plus that is going to be 147. Hopefully the same that you got as well. So again, the approach is the same. So make a note of the values that you know. Recognize the situation, the arithmetic series. So we're going to be using this formula here. Substituting carefully, do careful good work, and enjoy the success for a moment. All right, well, thank you, good people. We're going to finish this video. This is counted as a sort of an introductory type question. I'm going to do the second type that I showed you. It's where we don't know what the last term is. It requires a different formula. Same approach, different formula. All right, thanks. Talk soon. Bye.